Okay, so today we're going to be looking at transformations of graphs. So transformation changes the position or the size of a figure. Transformations can be applied to our parent functions. So we looked at parent functions a couple days ago. So we're going to apply transformations to one. We're going to only do it in absolute value transformations today. So again, our parent function for this is the absolute value function. So y equals the absolute value of x. So if we graph that, of course, if we plug in -2 into our absolute value, we get out a 2. -1, we get 1. 0 is 0. 1 is 1, and 2 is 2. So our parent function for this has that V shape. And that's what we're going to be using our transformations on. So here's where we can actually look at our calculators. It says using our calculators, we want to graph the following functions, then compare them to our parent function. We want to give a brief description of what happens. Okay, so here's our calculator. The way we do absolute value in our TI-84s is we use the math button, and we go over to number. So math, and we want to over arrow to num. And then it's our very first one. It says ABS. It's got a parenthesis. So when we do that, mine pulls up an actual absolute value signs. Yours will just say ABS parenthesis, unless it's the new updated one. Same thing, okay? Your parentheses will count as your absolute value signs for whatever you put in there. Now to actually put that into our graphs, we have to go to y equals, which again is that top left white button. And so I already have some in there. I'm going to clear those out. Again, absolute value is go to math, go over to number, and absolute value, or ABS. And I want to put in our first function. We have f of x equals x plus 2. So I'm going to type in x plus 2 into my absolute value signs. And so we want to compare it to this function. So if I do x plus 2 and I graph it, and the graph button is your top right white button, this is what happens with our graph. So notice, what do we do? What happened to our graph compared to our original? Shifted over, right? We had a full shift. We moved 2 units to the left. So f of x, when we add 2 on the inside of our parentheses, or inside our absolute value sign, we shifted. All right, we shifted 2 units left. What do you think is going to happen when we do f of x? X minus 2 on the inside of our absolute value signs. We're going to shift to the right. Let's see if that's true. That is exactly right. So this time we shifted 2 units to the right. Well, what about if we add on the outside of our absolute value signs? We have the absolute value of x plus 2. What do we think is going to happen on that one? Anybody have a guess?
It's going to go vertical.
It's going to go up. So when we add on the outside of our absolute values, we shifted up 2 units. So notice the difference between those. Inside the absolute values, we're shifting left or right. Outside the absolute value signs, we shifted up 2 units. So what do we think is going to happen when we subtract 2 units? We're going to go down. Okay. So again, we can check. -2. We graph that. It's exactly right. When we do the subtract by 2, we've now shifted our absolute value sign down 2 units. What do we think is going to happen when we multiply our absolute value by a value? So in this case, number 5, we're going to take our absolute value and we're going to multiply by 2. So what happened? Or did anything happen? Well, let's compare to our original. Here's our original. So what happened to its arms? They went in, right? So we were out wide. When we multiplied by 2, we got stretched upwards. Okay, so we got stretched up by a factor of 2. We got stretched by a factor of 2. So notice our slopes in this case, they were 1. We were going up 1 over 1, up 1 over 1. But now our slope is going up 2 over 1, up 2 over 1. So we got stretched by a factor of 2 when we multiplied by that 2. Well, what do you think is going to happen when we multiply by 1/2? Stretched by 1/2. Or we're actually going to call that one not so much a stretch, because that implies that we're getting taller. We're going to get shorter, so we're going to say we're going to compress. So we're going to say this is a compression by 1/2. Again, let's graph that just to make sure. So there's our new graph. And again, here's our original. So that's exactly right. So again, our slope in this case, we're going up 1 over 2 rather than our normal up 1 over 1 for our rise and run. So we compressed, right? We had that vertical compression where we smashed down towards that x-axis. And then our last one, we have f of x equals negative absolute value of x. So we've shifted left and right, we've shifted up and down, we've stretched, we compressed. What do we think our last one is going to be? Flip it. That's exactly right. So when we multiply by that negative, we're going to say this is a reflection over our x-axis. Right? We have that mirror image. Here's our original in the red. We flip right over our x-axis. So we have a vertical reflection or a reflection over our x-axis. Right. So now let's kind of make up some rules that apply for these. For f of x plus h, and you can look at that other sheet to kind of give you an idea. what are we going to do? When we add h on the inside of our parentheses, or again, we can think about it inside of our absolute value signs, what happened? We shift left, or I'm going to use a different word. We're going to translate left h units. And then when we have f of x minus h,
Translate right.
we're going to translate right. H units. What about when we have f of x plus k on the outside?
Translate up.
We're going to translate up. K units. And f of x minus k,
Translate down.
translate down. K units. So there's our translations. All right, we can go left and right. We also have another term for that. We would say these are our horizontal translations. And then we have our translations up and down, or we can say these are our vertical translations. And then our next is our dilations. So we have two of those that can take place. For a times f of x, where a is greater than 1, or the absolute value of a is greater than 1, what'd that do? When we multiplied by 2,
Stretch up.
we stretched by a factor of, in this case, a. So remember that changed our slope on our limbs, right? Whatever that a value was when we multiplied by 2, it changed our slope of those two limbs to a slope of 2, or our left limb would be negative 2. When we multiply by a, and a is less than 1, I'm going to say greater than 0, but less than 1, that's our compression. And again, by a factor of n. And then our last one, when we multiply by a negative, that was our reflection. And we're going to call this one a vertical reflection. So these are the main types that we're going to be dealing with whenever we're talking about our transformations. We do have a couple extra, and that's why I handed you that other sheet for our transformations of functions. So what we just covered covers all of our vertical transformations, right? We can add or subtract. We can multiply by a negative. We can multiply by a value greater than k or greater than 1, or a value greater than 0 and less than 1, where we have our compression. But we also have 2 more, or 3 more really, and that is our horizontal transformations, where we're on the inside of our parentheses or absolute value signs. That is, we have a horizontal transfer or horizontal reflection, where we actually deflect across the x-axis. And then we also have our compression and stretch. Now our horizontal compression and our horizontal stretch work almost the exact same way as our vertical stretch and our vertical compression. So notice on our paper we have B is greater than 1. We have that as a horizontal compression. I'm going to say HC for horizontal compression. What that does is we compress toward the y-axis by a factor of B, or by a factor of 1/2 B. So what that's saying is you're taking those values from the outside and you're pushing in. Well, if you take something and you squeeze from the insides or from the outsides, what that does is that pushes the insides up. So that's why it has that same effect as our vertical stretch, right? If you take something and you squeeze it like a ball, that ball is going to be pushed up. But if we've shifted off of the y-axis, it'll also move us towards that y-axis. Okay. And we also have our horizontal stretch, which is where we take our object and we're pulling from the outsides, which would be the same effect as that vertical compression. And we'll see those, but those are kind of rare cases that we'll look at. And then the last thing is, whenever we're graphing these transformations, we kind of have an order that we need to follow. So our first order is our horizontal translation. So we need to either move left or right. And again, that's our addition or subtraction on the inside of our parentheses. The next is our horizontal reflection and compression and stretch. So that's when we're multiplying on the inside of our parentheses or absolute value. And then our third is our vertical stretch or compressions or reflections. And then the last one is our vertical translations, where we shift the graph up or down. Okay. So let's look at a few of these from today's homework and do them together. So what we're going to do on this, we're going to graph these, and we're also going to say what transformations are taking place. And we can abbreviate a lot of these. Rather than having to write out vertical translation up, we can say VT and stuff like that. We're going to abbreviate those first two words with just their initials. So like number 1, we have y equals the absolute value of x plus 3. So what's going to happen on this one? We're going to shift left, right? So here's our original graph. We have x plus 3 on the inside of our absolute value, so that is going to shift us to the left 3. So our vertex is now at -3, 0. We don't have anything else happening on there. So we had a horizontal translation, left 3 units. All right, we shifted left 3. So that's our horizontal translation. We just abbreviate that HT, left 3 units. Now let's look at number 2. So number 2, we have y equals negative x plus 4 minus 2. So we have a little bit more happening on this one. Again, here's our original function. Again, just like with PEMDAS, we want to work inside the parentheses or work from the inside out. So we have x plus 4 on the inside. So what takes place first? X plus 4. And what is that plus 4 going to do? We're going to shift to the left. So we have another horizontal translation. This time 4 units. 3, 4. So that's where we're at now. We've shifted to the left 4 units. Now we go to the outside. We're multiplying by a negative. So what does that negative on the outside do?
Shifts us down.
Shifts us down, right? It's gonna be our vertical reflection. So now we're gonna be upside down. And then what's the last thing that we do on this one? We subtract by 2 on the outside. So if we subtract by 2,
I have a question.
Uh-huh.
How is it considered a vertical reflection if it's going over the x-axis? Because
so remember the vertical reflection, we're vertically reflecting over that x-axis. So the x-axis is our reflection point. Okay. Good question. And then the -2, the very last step.
Bring us down to.
We're going to take us down to. So that's our vertical translation down 2 units. So that's going to take our vertex down 2. And there we go. There's our steps, right? Start on the inside. We added 4, we do the opposite. So we move to the left 4. Then we multiplied by a negative, so we had our vertical reflection. We reflect across the x-axis. And then we subtracted 2, so that shifts our whole graph down 2 units. Okay.
do we have to add all the steps on our graph or just the end?
You can just have the end result. However, I feel by having those steps, you're less likely to make a mistake. Right? To think about all the steps at one time, shift 4, I'm upside down, I'm shifting down 2, can be a lot. And so if you just lightly draw your steps as you go, I think it's a little bit easier. All right, so pick a couple more. You can pick off the back page too. Are there any of those that you want to do?
Well, you know how you,
Number 10? Yeah.
I was asking,
For what?
I was asking.
So number 10, we've got y equals 2, x minus, or x plus 1, minus 3. Okay. So again, we want to start on the inside of our parentheses, or inside our absolute value sign. So what's the first thing that happens? We're going to shift to the left 1. So horizontal translation left 1 unit. Then what happens on the outside? We multiply by 2. Think about it. Multiplying by 2, we're getting 2 times as tall. So this would be a vertical. Are we stretching or compressing when we multiply by 2? Stretching. This would be a vertical stretch by a factor of 2. So again, that's going to change our slopes. They are 1, 1, or up 1 over 1. Now they're going to be up 2 over 1. So we're getting narrower, right? We're getting pulled up as we go. And then our last thing, minus 3 on the outside,
Brings us down to.
down 3, right? So we have that vertical translation down 3 units. We're going down 3, Still going same slope of up 2 over 2. So there's our graph.
Wait, up 2 over 2 or up 2 over 1?
Up 2 over 1. Sorry. Thank you. All right. Any others you want to do? Or are we good?
Welcome.
11? Number 11. We've got y equals 3x. Our absolute value of 3x plus 3. So again, our original function is there. So our first thing that happens, we are multiplying on the inside of our absolute value. So in this case, we actually have a horizontal compression. We're going to be squeezing in the insides by a factor of 3, or by a factor really of 1/3. It's the opposite of what we think. So we're squeezing in by a factor of 1/3. Again, that has the same effect though as if we were stretching by a factor of 3. So going up 3 over 1. Especially because we haven't shifted to the left or to the right before we're doing that. And then the last step, we're adding 3 on the outside. So that's going to be another vertical translation up 3 units. Up 3. There we go. So again, this is on that second sheet I handed out, that horizontal compression.